Okay, we already discussed how to describe the direction of a vector. So we know there are three ways to describe the direction. It could be with reference or with respect to the x-axis, with respect to the y-axis, or it could be in standard angle. So regardless of the direction, no worries, especially when we will be dealing later on with vector addition. However, for simplicity of our discussion, we are going to use standard angles. Okay? We are going to use standard angle. So for example, if we have a vector, let's say vector denoted as r. So that is our vector r. We can also describe the direction in terms of angle. We have in here the standard angle, theta. Okay, yun. So we have the standard angle denoted as theta. So every time you will see theta, it refers to the standard angle. So suppose we have vector r with respect to a certain angle, we can determine its horizontal component. Let us call it Rx. That's the horizontal component, meaning that's the component along the x-axis. So that is why there is x in there, Rx, or component along the x-axis. There is also a component along the y-axis, or the vertical component. That's Ry, vertical component, y, vertical axis. The horizontal component, Rx, which is, of course, along the x-axis. So again, we have r, which is the vector. We have, at the magnitude of our vector, we have ry, the vertical component, and rx as the horizontal component. If you observe, what we just made is a right triangle. Okay? We just created a right triangle. And based on your discussion in your pre-calculus class, we can label the parts of a right triangle. We have the longest side. We call it as the hypotenuse. Again, the longest side is the hypotenuse, or that is the side opposite of the right angle. So if this is our right angle, the opposite side is called the hypotenuse. We also have the adjacent side, meaning that is our reference angle. That is where our angle is being attached to. So tapad siya sa angle. So that's the adjacent side. And we also have the opposite side. That is the side that's the side being faced by the angle. So our angle is facing the opposite side. Good. Now, we can describe the trigonometric functions based on these parts of the right triangle. So you already know that there is sine of an angle, there is cosine of an angle, there is tangent of an angle. In fact, there are how many? Six trigonometric functions. We also have secant, cosecant, cotangent. But we are going to focus on SOHCAHTOA because that will be useful during our discussion. So we have sine of an angle is opposite over hypotenuse. This is just a review because I know this was already discussed in your pre-calculus subject. We have cosine of an angle adjacent over hypotenuse. We have tangent of an angle opposite over adjacent. So with reference to our vector, our opposite side is ry. So that's ry. R is our hypotenuse, that's the magnitude of our vector. Our cosine Rx, that's our adjacent side. R is our hypotenuse. Tangent Ry is our opposite side. Rx is our adjacent side. So that means if we are going to determine the vertical component first, if we are going to get the vertical component, which is Ry, we can just cross multiply. That gives us Ry is equal to R sine of an angle. So that's the formula for the vertical component. Again, I would like to emphasize that the angle should be in standard angle, okay, standard form. We are going to discuss that during face-to-face classes next week. Why is it necessary to convert into standard angle? We are going to discuss that next meeting. So again, this is the vertical component. And also, our horizontal component Rx, we are just going to cross multiply, is equal to R cosine of an angle. This is our X component or the horizontal component. Good. So Ry is sine, Rx is cosine. So for example, we have this vector, 15 newtons south. 15 newton going south. How are we going to determine the X component and the Y component? Let's first use the standard, what we just agreed in the previous slide, that Rx, that's the horizontal component, is R cosine of an angle. And our Ry is R sine of an angle. So in this case, what is our angle? In this case, our angle is what? That's south. So our angle is 270 degrees. So theta is 270 degrees. Theta, that's south automatically. A late turn. So theta is 270 degrees, meaning that is 15 newtons multiplied by cosine of 270 degrees. And that will give you zero newtons, right? Because there is no horizontal component of our vector. It is only the vertical component. So automatically, if there is south, north, no need to use. But again, I'm discussing the standard procedure. But if you notice, our vector has no horizontal component because it's only south, right? Along the vertical component. So now, our Ry is 15 newtons multiplied by sine 270 degrees, and that should give you negative 15 newtons. Why is it negative 15? Why is it negative? Yeah, so why is it negative? Because of course, in your pre-calculus subject, you know that if it is along the negative y-axis, y is negative, right? So 0 and negative. Good. Okay, so that's negative 15 newtons. Let's have another example. Suppose the Diwata 1, a Philippine microsatellite, is located 1,165 kilometers, 25.8 degrees east of south. So let's write the vector. We have 1,165 kilometers. That's the magnitude. And our direction is 25.8 degrees east of south. East of south. Again, the first thing to consider is to convert our direction into standard angle. So we need to convert that into standard angle. We know this is 25.8 east of south. So we are from the south going to the east. So that's this one, from the south going to the east. So that's our 25.8 degrees. Do you follow? From the south going to the east. And we know that we can determine the standard angle from 0. This is 0. And rotate there. So this will be our standard angle. And our standard angle is just, we know this is 270, right? But it extends beyond 270. Again, it extends beyond. So it should be 270 plus 25.8. And that gives us what? 295.8? Am I right? Degrees, 295.8 degrees. So our standard angle is 295.8 degrees. Clear? So we can get our horizontal component Rx, which is just R cosine, again, X is cosine of an angle, and our Ry is R sine of an angle. To substitute, our R here is 1,165 kilometers multiplied by 25.8 degrees. And not 25.8, sorry about that. Again, we are going to use the standard angle. That's 295.8. 295.8 degrees. Sorry, it should be cosine. What happened? It should be cosine 295.8. 295.8 degrees. But cosine, cosine, okay. Cosine of 295.8 degrees. Cosine 295.8 degrees. That gives you what? By the way, make sure that if you are using the scientific calculator, make sure that your calculator is in degree. So you can see it's in degree because on the top of your calculator, there's deg there. Baka kasi naka-radian, so magkakaroon ng error. So make sure nasa top part ng calculator, there is deg. Okay, so that is 1,165, sorry, 1,165 times cosine of 295.8 equals. That's 507.0442 kilometers. Sorry. Now, for RY, we have 1,165 kilometers multiplied by sine of an angle. That's 295.8 degrees. That's 1165 times sine 295. 295.8. That's negative 1,048.871 kilometers. Okay, so why is it positive x and negative y? Why? Why is it our rx is positive and our ry is negative? Bakit kaya? Because it is in? That's for you to discover. I will ask you during our next meeting. Why is it positive Cx and negative Cy? Now, how are we going to report our answer? If you notice, there are so many significant figures, right? So to round it off, how are we going to report our answer? Again, the principal rule is to round it off to the least number of significant figures. How many significant figures do we need? So here there is 4. Here there is also, in the 25.8, there is 3. In 1165, there are 4. So we need only 3 significant figures. So this should be 507 kilometers. And this should be negative 1,050 kilometers. Don't worry, we'll discuss that during our next meeting. So again, ngayon, ang gusto ko lang maintindihan ninyo is for the horizontal component, we will use cosine. For the vertical component, we are going to use sine. However, the angle should be in standard angle. That's very important. It should be in standard angle. Okay, for your formative assessment, kindly answer these practice exercises. Let's add one more. Let's have 283 kilometers, 30.5 degrees south of east. Okay, kindly answer those 3 problem sets. Not 3 problems, 3 problems. Okay, I'll give the answer key within this week.